All right, so this is lesson 2.4. What we're going to take a look at today is something that we've done in the past, specifically around completing the square, and then using that process in a different way to also do something else that we've done before. So just an alternative. Today is an alternative lesson to things that we've done in the past while still brushing up on a skill that I think you need in the future. Okay, just the contextualization of what a vertex actually is. So completing the square. The first thing we're going to start with here in problem 1 is the identification of some constant value that turns or makes a perfect square trinomial. Okay, because we're going to see in the second part of this that the perfect square trinomial component of completing the square is actually very important, right? So what we're going to do here, okay, by definition, a perfect square trinomial means that when I write out my man factor, or my factoring game, if you will, I'm looking for what number I'm going to multiply to. And for instance, in question A, maybe I should just move this down here as an example. In question A, I'd be looking for two numbers that added to 6. Sorry, I don't know what I'm doing. 6, but multiply, I don't know, right? And we know that whatever the numbers are, they have to match. Okay, so adding to 6, let's think of the things that add to 6. So 1, 5, 2, 4. And remember, for it to be a perfect square trinomial, it has to be the same number. Well, the same number that adds to 6 is 3 and 3, which not coincidentally, it multiplies to 9. So that's going to be your C value, right? And so when I go to write this as a perfect square trinomial, I can go x squared plus 6x plus 9. And when I factor this using the two factors that I have, I'm going to get x plus 3 times x plus 3, which then condenses down into x plus 3 squared. Okay. This is a very important part of the completing the square process. You can see here, okay, there's an a value of 1 and no what we would have written as a k value in grade 10. Okay, so there would have been no vertical component or translation up and down. This would have been a horizontal translation to the left, 3. This is pretty close right now. Well, it is now in vertex form, I'm sorry. Okay, and so what we're doing with this completing the square process is we're looking for the vertex of the quadratic. In this particular instance, it would have been 3 and 0, right? So it's lying on the x-axis. Okay, now this game can get quite difficult, right? It's not always, these two numbers are not always going to be nice numbers like they are in the first 3 questions. So there has to be a way to be able to come up with that number easily. Okay, and what that is in grade 10, if you've seen any of my videos or if I had you, we find what we call a z value. And we define the z value as being the b value of the quadratic. Remember, quadratic written in standard form is going to be ax squared plus bx plus c. So specifically, it's this. You can't see that. That's not very good. That number right there. Okay, so it's, maybe I'll change colors. So it's the b value, this z component I'm referencing. Z is going to be the b value divided by 2 squared. Okay, and for this particular question, or if I really wanted to, actually what we'll do is we'll prove it to you in the other question, right? So what we'll do is we'll say, okay, z is going to be b divided by 2 in the last question, squared. That is going to be, the b value is 6. 6 divided by 2 squared, 3 squared, 9. Okay, this always works for the identification of the C value that creates a perfect square trinomial, right? There's 2 important things here. One is this number as the C value. The other important thing is whatever this number is before you square it, including the sign, is actually the thing that goes on the inside of your round brackets for the vertex. It'd be like the horizontal translation of your vertex, or of your quadratic, if you will. Okay, so that's important. We'll reference that back in a sec as we start actually trying to do the questions. Okay, so for this one, the C value that's going to create the perfect square trinomial is going to be, let's run through it. -8 divided by 2 squared is -4 squared, 16. So that turns this into x squared minus 8x plus 16. If I were to try and factor that, I'd be looking for two numbers that multiply to 16 and add to -8. Well, that sounds to me like -4, -4, right? And so we get two pieces of information here, right? One would be like almost the y-intercept of the quadratic, or of this particular quadratic, as well as I also am able to identify any sort of horizontal translation that's occurred when I write this out, because I know the two numbers when I go to factor a trinomial, specifically a simple trinomial, it would be x minus 4 times x minus 4, which condenses to squared. So that little piece of information, whatever the number is before you square it, that's what goes inside there. That's your horizontal translation. Okay, if I were to do it again, because we're getting quicker, you can get the b value divided by 2 squared, which is going to be -12 divided by 2 squared. It's -6 squared is 36. So this is going to go into the c value that makes this a perfect square trinomial is going to be 36. And this now condenses into, very quickly, where'd the x minus 6 come from? I can slot it in there, call it a day quick. Okay, so a lot of this is going to be about efficiency and being able to do this quickly in the interest of trying to get to the vertex and answering word problems around the vertex. Okay, so what we're going to do down here, we're just going to quickly go through these ones. Okay, there is one catch with this process, as you would have learned in the past, in that I cannot do this process unless the a value of the quadratic right here is 1. Okay, so we're going to have to do some factoring out of the a value in order to apply this process. Okay, so I'm just going to go through this quickly. I'll do the first one a little bit slower, but the second one we'll go through a little quicker. Okay, so what we're going to do here is the same game. Now what you're going to notice here, we're going to try and maybe do something like this. Plus c. Now, I'm not allowed to just add some random constant value. Okay, but what I am allowed to do, if I choose to manipulate an equation, if I manipulate one side, I'm also allowed to manipulate the other, using the exact same thing, right? Because that's effectively not doing anything, because what's going to happen here is if I can zero pair this and move it over, right, by minus c, that's the reason why we're allowed to do that. Okay, what I've done to one side, I've done to the other. I haven't changed the equation. I'm just strategically manipulating it in order to do something. Okay, so what we're going to do, that c value is z. That's the thing that I'm going to add and subtract. And don't forget about that -2 that's in the question. Okay, so what we're going to do here is find the z value. Okay, we don't need that plus and minus c now there. And then when I find the c value, it's going to create a perfect square trinomial right here that I can condense down into something x plus or minus something squared, and then I'm going to have the minus and the minus there to deal with as well. Okay, I'm going to get my vertex. So that's the process. Okay, there's a minor manipulation of what's there in order to create a perfect square trinomial that can condense down into being able to identify where that vertex is gone or where the graph's going. Okay, so what we're going to do here, let's find the z value. The z value is going to be the b value divided by 2 squared. Okay, so just trying to find where the best place to do this is. So Z is going to be 4 divided by 2 squared, which is 2 squared, which is 4. So we're going to go y is equal to x squared plus 4x plus 4 minus 4 minus 2. Okay, we're going to get y is equal to, the first three are going to condense down into x plus 2 squared. Where did the plus 2 come from again? Right here, the number before you square. The number before you square the b divided by 2. Okay, and then you have the minus 4 minus 2 on the end. And we're going to get y is equal to x plus 2 squared minus 6. So my vertex is going to be negative 2, negative 6. Okay, that's a graph that's been moved, translated horizontally left 2 units and down 6. Okay. For the next question, this is what I was referencing before. We need to get rid of that factor of 3 there. Okay. So what we're going to do, factor it out. Okay, and we're going to get y is equal to 3 x squared plus 12, plus 4x. Now here's the thing, this value, if I factor the 3 out of that negative 4, I'm just going to distribute it back in at the end. Okay, so I'm going to just selectively factor out of the first 2 terms, and then I'm going to leave that minus 4 at the end because it's not going to change anything when I go to multiply it back in at the end. Okay, now what else? I'm also going to introduce this notion of square brackets because in a second I'm going to introduce round ones as well, just to keep a difference from the outside to the inside, right? So now again, this is like a last question on the inside. I'm going to add 2 and minus 2, or sorry, add 4 minus 4 because the b value divided by 2 squared in this same trinomial, what will be a perfect square trinomial will be that plus 4 minus 4 when I find the z value. Okay, so we're going to get y is equal to 3 x squared plus 4x minus 4, sorry, plus 4 minus 4 minus 4 on the outside. We get 3, first 3 condense into x plus 2 squared minus 4 minus 12. Okay, and now I'm going to get rid of those square brackets. I'm sorry, minus 12. I'm one step ahead here. Okay, I'm going to distribute that 3 in. It's going to stop at the round brackets. And so I finally get that minus 16. And so the vertex here is going to be negative 2, negative 16. Okay. Next one. Again, factor out that negative 2. Okay, don't touch the last term because it doesn't affect anything until the very end. Okay, and now you're going to go, the z value here is negative 6 divided by 2 squared, which is negative 3 squared, which is 9. So y is going to be negative 2x squared minus 6x plus 9 minus 9 square bracket minus 1. First 3 create a perfect square trinomial. Specifically with that x minus 3, like negative 3 are the factors that satisfy the multiplication to 9 and add to negative 6. Okay, this is really honestly just the same thing over and over again, this process. Okay, in order to arrive at the vertex. So now I'm going to distribute the negative 2 in. Okay, and so your vertex here is 3, 17. Okay, we got one more for you, and then I'll break this video up into two, and then we'll practice actually graphing. Okay, so y is equal to, factor that negative half out. When you factor out a negative half in this question, oh, there should be a squared on there, you're going to get x squared plus, okay, because negative divided by a negative is going to be a plus. So it's plus, and then 1 divided by a half, or negative a half, is going to be 2x. Okay, and leave that plus 4 alone. And then I'm looking for the z value of b divided by 2 squared, which is 2 divided by 2 squared, which is 1. Okay, and so we're going to get 1 squared is 1. So we're going to get x squared plus 2x plus 1 minus 1 on the inside plus 4. X squared, x plus 1 squared minus 1, close the square bracket, plus 4. Distribute that negative a half in. Okay. And then we're gonna need to create a common denominator here over 2. So we're gonna get negative a half x plus 1 squared plus 1 half plus 8 halves plus 9 halves. Okay, and so the vertex for this question is going to be negative 1 and 9 halves, which would be 4.5. Okay, so hopefully this video serves as just a little bit of a recap of grade 10 completing the square. We need this process in order to do what's coming next in the next video, while still being able to produce the graph of the quadratic. Okay, so that's where we're headed. Remember, if you're looking at your flow chart, this is taking something from written in standard form and writing it into vertex form so that I can identify the maximum or minimum, right? Depending on whether or not the quadratic's opening up or down. If you recall, when we graphed lines in the past, we would only ever need 2 points to create a line. We've discussed that a number of times. With a quadratic, I think the bare minimum number of points in order to produce the quadratic is going to be 3. So what we've done effectively is found one of them for sure. The one very good thing about standard form is it identifies the y-intercept, so that's 2, okay, but we need 3, okay, and so what we're going to try and do is find the x-intercepts using this process instead this time. That's a slight alteration from grade 10. We have many ways to solve for x-intercepts, and that's what we're going to concentrate on here. Okay, so take a look at the second video. Hopefully this is a nice little recap of completing a square for you. We're going to need that moving into the next part of the lesson.